Hello everyone, and Max is going to give us a lecture about protecting web applications with free and open source software.
Thank you very much. Hello everyone. Hope you're not too tired from last night, Reiki night. All right, small eyes from some people. All right. So it will be an easy entry talk. We talk about how we can protect web applications and using free open source software because we need not cost-effective solutions, and many solutions are very expensive. So I will talk about. Let me just. It's frozen. All right. All right, then. I think my screen is frozen, so I will unplug it and plug it back. You know, it's never good talk if you don't have a problem. All right. Yeah, it's back. So my computer is back on. So it should be. Yeah, no, it freezes on full screen. Yeah. So let me just get this in full screen mode. No, it's frozen again. All right. Feed page. I'm sorry. I think you will. No. I have a problem. The slides are not moving. Try with PowerPoint. Wait. All right. No, the screen froze again. We tried it an hour ago and it was fine. Okay, thank you. Yeah. All right. I'm back. Yeah. Is this moving now? Oh, yes. Thank you very much. It's moving. All right. Thank you. All right. So let's start Internet Explorer. Yeah. So my name is Max. Maybe you saw me at the entrance because, yeah, I like to talk to people a lot. I'm working as a security architect in a small company in France called Comect. We're working on a project called MyDID, which is decentralized IDs and verifiable credentials. It's new W3C standard. And yeah, if you would like to know more, just come to me. So what are we going to talk about? We are going to talk about very quickly what is a reverse proxy, because maybe you know what it is. If you don't know, you will learn something. What is a WAF, Web Application Firewall? We will talk a bit about what we needed to protect our apps, and then you will have a benchmark, because there are some open source solutions that you can find online, and we'll try to see how it fits heavy loads. Because that's always the thing that you want to know. Light load is always fine, but what about heavy loads? And then we'll try to be a bit more on the banhammer side with fail-to-man integration. So what is a reverse proxy? A reverse proxy is a way not to expose your web applications to the open world, to the internet. The risks, if you don't use one, is it's not easy to load balance or to do cache to improve speeds on your application for static pages, security considerations, SSO integrations, etc., etc. So the goal of a reverse proxy is to allow external users, internet users, to access internal instances of your web application in a private network. It's like HTTP routing, if you'd like. The fact is, it creates a second TCP connection. So you have a first TCP connection as a user to the reverse proxy and a second one to the instance of your application. You have some reverse proxies that don't do the protocol breaking at the middle on the reverse proxy. They are called transparent reverse proxies. We will not talk about this one in this talk. So why? Why a reverse proxy? To do a load balancing, have multiple instances of your application, and to easy load balance them depending on the metric, which is CPU usage, load average on Linux, maybe open connections. You will try to route the request of the user to a less used instance of your app. On the cache side is, because you're in the man in the middle, you can use cache, like varnish cache, to store static pages and give them back. And on the security side, it isolates your application from the background noise of the internet, you know that. Port scanning, etc., happens all the time when you have a public IP address. You can keep your VMs in a private address space, which is better. And why not check there if you receive something from the outside world that may look like an attack, you know, and maybe block it before it goes to your application. So you can use web servers as reverse proxies. Maybe you've done it before, following tutorials on the web. So Apache HTTPD. You can use proxy pass, proxy reverse thing. It does this. And also Nginx. People in French call this Nginx. I don't know why. It's French way to say it, but Nginx is great as well. But both are good, but not good enough for heavy loads, you know? And I'm going to show it in a few seconds, in a few minutes, when we talk about benchmarks. You'll see a difference between Apache 2 alone and reverse proxy, then Apache 2 behind it. And you'll see that there are some differences. There is one open source and free software that is well known for reverse proxy applications is HA proxy, high availability proxy, which is really good. You can use the community edition, which is free and available, let's say, in the Debian repositories, for example. It's a well-known and well-made reverse proxy for load balancing. High availability, works at HTTP level or TCP level. You can even reverse proxy RDP connections, remote desktop protocol connections, or SSH connections. It's really nice for this. It's used by many big companies like GoDaddy, GitHub, Bitbucket, and you know what. And if you use 6 to 8 cores, CPU cores, you can manage 200,000 to 500,000 connections per second. So it's a lot. What is great as well with HA proxy is the SPO star. SPOP, SPOA, SPOE. What is this? It's, let me just, stream processing offload protocol engine and agent. So the protocol is binary protocol between HA proxy and an app that you develop that implements this protocol. And what it's doing is expanding the capabilities of your HA proxy instance. So if you want to do cache, if you want to do security checks on your requests, this is what you will want to use. It's a plug-in way to do things, you know? So if I'm talking about this, because it will be used by the firewall, the web application firewalls that we are going to see in a few minutes. So what is a web application firewall, or we call WAF? What is it? It's the last security line of defense before your code application. It can work with rules. So you have a big set of rules that you may already know about. We'll talk about them a bit later, called OWASP core rule sets. Do you know about them? Somebody heard about OWASP core rule set, CRS? Yes, some hands, all right. They will do also protocol enforcement, so checking the size of requests, content length, posts, data, all the headers, etc. And you have some sellers of WAF solutions that sell you an AI augmented WAFs, but you have the same problems that you have with AI technology in the defense side, which is to say that the training is long. You have to give the AI a lot of requests to learn good and bad requests. And you have always the same problem is what happens when there is an attack during the learning phase. It will learn that this is not an attack and it will go through every time. So it's not that easy. Just remember something that is really important is a WAF is just a fail-safe. Nothing prevents more a web attack than good code, good quality code. So first things first, you have to check with SAST solutions your code, your application code, not to have injections, etc., to be fine. WAF is just a fail-safe in case a developer is not in the right mood or has done a rakia leak the night before and has small eyes, so you have to protect them. So without any reverse proxy nor WAF, an attacker from the outside world can attack your web applications right on front. If you put a reverse proxy, it's not better because the reverse proxy by itself doesn't do any checks on security side. So what you will want to do is to add a WAF functionality to your reverse proxy. So an attack will go to your reverse proxy, will be sent to the WAF for analysis, and depending on the WAF, it will return allow, deny, or a score that you will allow or not allow in the reverse proxy, and you will be able to send a standard error page instead of forwarding the request, which is an attack, to your application. So, things to consider when you're using a WAF inside your architecture. Block everything is the WAF if the WAF is not responding. Because if you allow everything by default, that means that if the WAF is down, you have no security check on requests. This is not something you want. You want to block if no WAF is responding. The WAF is then a single point of failure, just as a reverse proxy. So you have to be careful to have multiple instances of your WAF for you to be protected. And then you understand why stress testing, benchmarking WAF solutions, even free open source software solutions, may be good because you learn how it manages heavy loads. And this is what we are going to talk about in a few minutes. So what WAF solutions do we know about? So you know Imperva, there was a talk about Imperva earlier in BalCon. Cisco, all the 40 solutions, Storm Shield, IBM, all have WAFs. But the problem is I'm from a small company. You know, we are 10, 12 people. So we don't have a lot of money to put inside these things because sometimes it's 5 figures. So we can't afford this. And you know Cloudflare as well, maybe. So it's cheap. You have to forward. In fact, Cloudflare is your reverse proxy and WAF at the same time. The problem with Cloudflare is it's an American company. So NSA, Prism, Cloud Act, etc. And we don't want to give our users data to these companies, right? So we have to find something else. One of the big things ruling proprietary and free open source solutions is the core rule set of OWASP. There are free open source rules. They check for many attacks: SQL injection, XSS, path traversal, PHP injection, etc., etc. It's not bad. It's heavily maintained, updated every day. Sometimes you have false positives on your solutions because the WAF is a bit too sensitive about some names. We had problems with JSON objects where we have a dot profile picture. He sees the dot profile, he says this is a LFI trying to read the dot profile on the system, so it blocks out. So we have to put exceptions, whitelist rules, to be able to use our apps. But it's quite easy to do. The syntax is a bit hard to manage, but it's quite easy to do. And what about WAF engines that we could have, free open source WAF engines? We have 2 that are well known. One that is well known, and I think the other one you may not know. Who in the audience know about mod security star 1, 2, 3? Let's say 2 and 3 are the most used now. So it was created by Trustwave, and Trustwave just lent the Git repositories to the OWASP Foundation. So it's in active development still. The SPOA part is no longer in development from the HA proxy team. It's in C language, so yeah, C language is in orange at the screen. I'm not. It's not to bother people. It's because we had problems of memory leaking with the SPOA part of Mod Security 2. And it's compatible with the OS core rule set version 3. So note that I'm talking about Mod Security 2 because the free, Mod Security 3, is not compatible with HA proxy yet. So we have to do with this. And now, do you know about OWASP Coraza? Does somebody here knows about it? Yeah, Yes, 2 people, 3 people. Yeah, 3 people, but you read my talk before, so it's cheating. All right, that's great. OWASP Coraza is an OWASP project built to replace the Mod Security Star WAF engines. It's in active development, both the project and the SPOA part. It's written in Go, which is great because you have Go routines. It's routines that you can queue to treat many requests when you have to. It's really good. It's a compilation needed, but it's kind of easy. You have to install the right version of Go and do make, and it's compiled, where the Mod Security 2 SPOA is kind of pain in the ass to build. And it's compatible with the last version of CoreSet, which is great. So from here, you can see that I have a bit of I already choose which one I want to use, you know? But we'll check this with benchmarks now, because this is the real big thing. How do they manage the load? And you'll see it's not the same thing. So what did I use to do my benchmark? Only on local network. My benchmark tool is here. So this is a small Pelican-like case where I have a small server, you know, the small computers. I've put Proxmox virtual environment version 8. I have a small Wi-Fi router on it as well, 4G cell if I want, a small keyboard, a small screen, everything I need. I just have to plug it on the wall and everything works. So I've done many VMs with the same parameters on them, and we used a well-known tool called Apache Gmeter to stress test requests on Apache, HA proxy with Mod Security 2 WAF or with Coraza WAF, just to see how they manage the load. So what have been the parameters of the benchmark? It's 1 million requests in the smallest period of time possible. So it's really hard, eating really hard on machines. All machines have 2 CPU cores, 4 gigabytes of RAM, because this is what we are using in the production machines. And the timeouts, when there is timeout is 1 second, because it's a local network. So if my app, I'm getting a 1 second delay to get a response from a request, it's too much. And I've managed so to create 1,000 users at the same time with a runtime time of 10 seconds. This is going from 0 to 1,000 users in 10 seconds. And the loop counts of 1,000. So that's 1 million requests. So how did it went? First things first, the first thing I've tried is just Apache 2 alone and HA proxy in front of Apache 2. And what you can see, if you use Apache 2 alone, you will start to have errors, because Apache 2 can't manage this many requests at the same time. It's too much for him. He can't. And HA proxy is fine. If we are looking at response times, because that's something that is really important as well, you'll see that Apache 2, when it responds kind of fast. So we are in the 30 millisecond range. So it's kind of okay. But with HA proxy, we are about 100 millisecond range. Why? Because there is an intermediary machine that you have to go through. So it's a bit longer. And yeah, I've put, it's hard to see. I've put the smallest one on top of the longest one. So you see that there is a big difference. It's normal. We have a new machine in front of it, so it's normal. Here you have errors and well-done requests, well-responded requests. And as you can see, HA proxy had just few small errors, really not much. But Apache 2 was on full load, and it was giving timeouts on some requests. So now let's try HA proxy with Mod Security 2 and HA proxy with Coraza with editor configuration. That is to say, recommended configuration from the makers of the things. And that's not so good. For Mod Security 2, we have the big problems because the timeout of 1 second is giving bad failed answer for most of the requests, where with Coraza we had few errors of overloading, but it was fine. So if you want to see all the requests, so for mod security, if you can see, I don't know, you can see my cursor, right? Yeah. Here is the 1 second mark, and you can see all the requests, mostly all the requests are above the 1 second mark, you know? Where for Coraza, we have mean response time of 350 milliseconds, which is 3 times less than the mean on mod security, so it's kind of good. Yeah, it's a bit longer, but it's better. And then we have many hours on mod security because of the timeouts that has been triggered. And Coraza is better, not as much timeouts as the other one. So if we try to fix the configuration, it's not better. It was missing a max con, which is how much connection max it can manage. And on the SPOA part, you have to manage how many threads you want to run, and they must match. The numbers must match. We still have a lot of errors, not of detection errors, but a lot of timeouts. Look at Coraza, it has not moved much. But with mod security 2, we still have hitting the 1,000 mark, 1,000 milliseconds mark, so it's not good and not as responsive as we thought. So maybe you're thinking, maybe you've done something stupid. Maybe it's your configuration that is not good. Maybe, but you will see that if we load balance the WAFs, we'll have better response times with mod security, but still not as good as with Coraza. With Coraza, we have about 350, 400 milliseconds mark to get an answer. So it's not so bad. Yeah, here you have the errors. So with mod security 2, it's kind of bad. And blue is error and yellow is good. So as you can see, it's not good at all. And the last thing we've done to try to do the most lookalike to the production machines that we have is to load balance WAFs, because a WAF is an application and needs load balancing as well. So if we have 2 WAFs, maybe we can double the speed, right? Yeah, it kind of works. So now we don't have many errors either on mod security 2 or on Coraza. That's great. But on mod security 2, we have about 650 milliseconds of mean response time, which is not enough, I think, for local LAN tests. It's not good. You have to add on this the latency that you might have using the internet infrastructure. And in Coraza, you have about 230 milliseconds response time, which is a lot better. And not so much errors as before, well, nearly no errors. So yeah, which solution did we choose? We chose HAProxy plus Coraza because of the maintenance, heavy maintenance done on this, the OWASP core rule set 4, and the response time, which are quite good with Coraza compared to mod security 2. Just be careful that the GitHub repository for Coraza SPOA is still written as experimental. We are using this on production side for six months now, and we never had a single bug or failure or whatever. But just for you to know, I have to do the disclaimer, right? What you can do as well is to chain HAProxy plus Coraza, this we have already, and to change the HAProxy logs to log attacks detected from the WAF, to ban IPs for a certain time that have tried web attacks on your infrastructure, which is a really good idea because if you have front-facing applications, you will receive a lot of automated vulnerability testing, etc., etc. On average, every 5 minutes, we get a very big hit of I don't know, robot scanners, everything that's trying to get files and do path traversal attacks to try to get the .env, .conf.env files, etc., etc., trying to extract information about those. So the goal is to ban an IP for some times after an attempted injection. It's not hard to do if you know what you're doing. So we have to log useful things inside HAProxy logs, and then tell fail to ban, how to search for IPs and failed WAF checks, that means to say attacks, and then ban them. So I will go fast with this because I don't have much time. So we need to log the decision here, WAF action, 2 dots, and then this txn.coraza.action is the action that the Coraza has recommended to HA proxy, which is allow, denied, block, etc. Then your log line will look like this. So WAF action deny, which means that there has been an attack on this and we should stop it. Here the attack is trying to get the .env file. You have the rule here. You have the HTTP request here, which is an attack. And then you will have to create a filter rule for fail to ban to learn the pattern of the log file that you've created. So here is one. And then you have to create a GL for it. So we have 2 GLs, Coraza immediate and Coraza long. One Coraza immediate is you try 3 or 5 web attacks in small period of time, you're banned for small period of time. But if you do it too much on a long term, we'll ban you for 1 month or 1 year or whatever. It's kind of easy to do. And then you can check banned IPs. So if you would like to do the same thing as me, if you want to try, if you want to check what I said, because maybe my tests are not good, I've done my best to do them and to replay them. But if you want to get more into it, I created a GitHub repository where you can find these slides and all the tutorials, systemd files to automate the start and restart of WAF applications, all the HR proxy configuration files, compilation scripts, everything. You have all the tutorial there if you want to do the same thing on your infrastructure. Just be careful, fladnaG is with a 9 because the G was already taken, so it's FLADNA9 on GitHub. So, if you want to discuss with me about your experiences with protecting web applications with free software or whatever, you know where to find me. I'm always at the entrance. Thank you all for listening to me. Thank you to Frédéric Martin, the CEO of the company I work for. That has been a lot of support for this presentation. All the French friends that have took a look at my slides to try to fix things that were not properly explained. Thank you for BalCCon team for organizing this great event once again. And yeah, see you anytime. And if you have questions, now it's a time. Thank you very much.
Hi, thank you for the presentation. Do you chain any anti-DDoS solution together with this? Or some JavaScript challenges or something?
That's a great question. In fact, we do. So we have a protection from our provider. I'm not here to do any sorts of ads for a company. We are in a European provider that does the anti-DDoS protection. You can also use the same rules that you do on fail to ban, just to check normal requests, so not WAF action deny, but all requests. And if you receive too much, you ban. We are doing this as well. So it's not easy, it's not hard to do because it's kind of the same jails and filters that you have here, except you have to remove the WAF action deny inside the rule. But it's the same thing, So yeah, you can do this as well to ban DDoS. The problem with DDoS is that the network infrastructure inside a provider, you will not be able to protect. So they have to provide you with some kind of filtering as well.
Thank you. Can you add something like Suricata or?
Sorry, can you speak a bit louder?
Can you add something like Suricata or Snort on HAProxy?
Yes. In fact, we're using Proxmox virtual environments. We created a lot of virtual LANs, inside VMs. And you can put Suricata on the hypervisor, on the Proxmox virtual environment, and you can sniff all the networks inside. So behind HA proxy between HA proxy and your VMs. So we are doing this as well, yes. It's working kind of good. And the fact is that you can also send events to Wazoo CM if you're using it. So it's really good because you have a JSON output. So it's really nice to use. Is there any more questions? Don't be shy. I do not bite. So
I do have one. So
yeah.
Because you are doing your WAF by yourself and hosting, how much time it takes from you to maintain on monthly?
Monthly to maintain them. Most updates about rules, the core rule sets, and building can be automated with a bash script, so not so much.
Like 20 minutes per month.
Not so much. The first time it took a bit of time to do the bash script, but afterwards, not so much. Maybe I go there once a week to check if everything is all right. All the machines are monitored with Isinga. Do you know Isinga? It's a fork of Nagios. It's working the same. It's monitoring device, so you can check if the TCP port is open, so the solution is the WAF is running. So yeah, it's not hard to do once you have the scripts for it.
Okay. Somebody else?
All right. If you're too shy, come see me afterwards. Thank you very much, people. Have a nice day.